So my name is Bertrand Delacretaz. I come from la Broye fribourgeoise. Il y a des gens de la Broye ici? Payan, Estavayer, Yverdon? Par applause. Quelques-uns. A few people from my area, not many. The talk will be in English. I'm a principal scientist at Adobe, attached to the Basel office. We have an office in Basel with about 150 people, working mostly on experience manager, which I've been doing web stuff forever. I'm a web guy, to say. And I've also been, I was very happy to hear the last talk. I've been quite active in the Apache Software Foundation, sat on the board of directors for 14 terms, so I know it inside out, and it's really interesting, something to recommend. If you can, using open source is fun, contributing to open source is even more fun, and being involved in an open source foundation as a board director or something, or even, helping, that's also very nice. Can recommend it. My talk is on simplicity. So I'm really a generalist. In software, there's specialists. I have colleagues who've been doing the same thing for 15 years, and they're super good at it, and they're very deep. It's not me. I'm more of a broad generalist, interested in way too many things. That's my problem. But this talk is on simplicity, and maybe you can judge that I'm a bit older than some of the folks here. So I've been doing this for a while, and over my somewhat long career, I have a few examples where we really reached the goal of doing simple software. So I will first try to convince you of the beauty of simplicity and the importance of simplicity. I will give a few examples. So I will tell you about these things where that worked and how. And then third part will be about how to do it. Recommendation. I don't have a magic recipe. You will not leave this room. Oh, it's good. We know now. Bertrand told us. No worries. It's a bit more complicated than that. But I will give you directions, recommendations, advice based on my own experience. The first part is on the simplicity and the beauty of it. You will not be surprised by that I'm speaking about Lego. Many of us geeks, who is a fan of Lego? By applause. Yeah, many of us. I love Lego. I have a grandson who's almost 5 years old now, and I love playing Lego with him. I used to play Lego with my kids before that, a few years ago, and but I like the basic Lego. I gave the same talk in DevOpsDays Zurich a few weeks ago. And it was interesting because as a speaker present, I got the Lego box, the bonsai tree, very complicated things where you need to follow instructions. That's not my typical use of Lego. For Lego, I love the big bag of bricks. Improvise, do whatever. With my grandson, we build submarines who, if I showed them to you, you would not say that's a submarine. For us, it's a submarine, and we love it. So I love the simplicity of Lego, and I go even a bit further by loving simple Lego, the basic bricks, and then you can do whatever. This is also probably not very surprising, coming from a Swiss guy in a Swiss room. The Swiss Army knife, that's a pretty reasonable one, simple. It has all the essentials, screw, corkscrew, blades, 2 blades. Do you really need 2 blades? Maybe. But there's some counter-examples. Maybe you have seen the wide Swiss Army knife with 232 tools, including 231 which serve no purpose except selling the thing, maybe. So it can be a good example of simplicity, and sometimes people go overboard and destroy the simplicity. Maybe you did the same thing in software at some point. We have, I'm saying you, but it's actually we, because I did that many times as well. We have a simple problem to solve, and we put all these layers, Kubernetes and this and this and this, and we think we're Google, so we need to make it web scale, and in the end you have 2,500 users. Why did you do that? Do a monolith in whatever language works, do good tests, and that's it. So I think it's really important to keep this in mind and try to be as simple as possible, but no simpler. Simple should not mean simplistic. I'm also a musician, and I love the kazoo. we are chatting with people. I often annoy people with my discussions about kazoo. And it can actually also be an annoying instrument, but it's super simple. It's a resonator. It's a membrane. You hum in it, and it vibrates, and it's kind of a distortion pedal for the voice. And if you're looking for a kazoo, you will typically find that kind of model, which is, I think the design dates back to the 1930s. And why stay stuck in the 1930s? So I have a 3D printer, I have software to do 3D design, and I designed my own kazoo, which sounds much better. And we use it in our band, and you know, I play solos on blues and stuff. And we had a concert last Saturday, and then I asked people from the audience, I said, did you find it funky or, you know, funny or not good? And I said, no, it was fun, it's different. So I'm going to show you. So you also get an acoustic memory of this talk. Voilà, pendant qu'une charmante hôtesse arrête le micro. So this is the 1930 version. I'll try to play something. Lots of effort on my part for not much. It's a bit of a, you know, it sounds like a toy. It is a toy. Why stay stuck in the 1930s? Why be simplistic? So this is still a simple instrument, but done with today's technology. Thank you. Thanks. Including good sounding bass, which you don't get with a 1930 version. My point, you probably did not come here to hear me play kazoo, I suppose. Maybe you did. If you did, that's very nice of you. But my point is that you shouldn't, it's great to be simple, but it doesn't mean you have to be simplistic. You know, if you are, that's a simple instrument, but why stay stuck in the 1930s? Do what we can do today with today's technology while remaining simple. And it's not easy, as we'll see. Creating simple stuff often takes more work because you rarely hit the simple thing on the first try. It often takes many iterations to get there. Another example to show this tension between simplicity and being simplistic. You might have heard this joke that the NASA, the American Space Agency, spent lots of millions to create a pen that works in space. You know, there's no gravity, it's a bit complicated. And the Russians, they used a pencil, of course, very easy, you know. But it's not that, it's fun, but it's not totally true. I mean, can you imagine a pencil with small particles of graphite in a space shuttle where there's lots of electronics and stuff? You don't want particles of graphite floating around. So actually, it shows that simplicity also needs to be appropriate. It should also not be too simple. You have some requirements for your thing, and you have to meet them. So that's, simplicity is not as simple as it could sound. I have some AI in my talk. Nowadays, you have to have some AI. I used AI to generate this image. It's probably the only AI that I have in this. But it's also something that's becoming more and more important. The stuff that we create tends to use lots of power. And if it's simpler, it can often use less power, which is a good thing nowadays, and more. So it's also another benefit of being simple is that your software might be greener, might use less energy and be better for the planet. So simplicity, you can tell by now that I'm a fan of simplicity. I think there's beauty in simplicity. There's lots of beauty. But it should not be simplistic. It should be appropriate. You have to find the right level, be as simple as you can, but not simpler. The quote is not from me. And that's really a challenge. So you might come out of this talk with more questions than answers, but I hope these questions will help you, move in the right direction towards simplicity. Now to the examples. The first one is from around 1993. I know some people in this room were not born at that time, but I was, and I was already doing programming. And this was for a company who does road management systems. So in Switzerland, we used to have lots of snow in winter. It's not as bad as it was, but still. And then this company helps the road management agencies. They measure the freezing point on the road, and then the road management agency knows if they need to go out and put more salt or if it's already good. So it's good. You save money, you save the environment and all that. Basically, a network of weather stations, not tens of thousands of stations, maybe 1,000. At that time, we did the whole equipment of Bavaria in Germany, and that was maybe 500 stations or something. Giving out data every 2 minutes. Every station gives a new record every 2 minutes. It's not big. It's just a few, temperature, pressure, maybe like a tweet from the good days of Twitter back then. 80 or 100 characters something, but hundreds of stations spitting that out every 2 minutes and forever. And you have to store this. So we thought, how can we store that? Of course, database. You put that in a relational database, then you can do queries, and then it's fun, and it's good. And that would be the typical, that was probably our first idea, I don't remember. And then you look at it and say, do we really need the database? The problem was these things were out in the field. They had to be as simple as possible, so nothing breaks. It was really important to get to the simplicity there. So we thought a bit more about it, and I don't remember how long it took, but it probably took a few weeks, maybe a few months, to get to the good idea where you say, oh yes, this is simple, and I can explain it to my colleagues in 2 minutes over coffee. What we did is create a chronological tree of folders with the names, year, month, day, and so on, 2025/05/20. That's the folder for today. And then in the folder, you store files. I think that was, in this case, a few minutes of data in one file, which is, has a very simple index. And then the query, we realized we only needed to query for data over a given period of time. Very easy to implement on that thing. I can explain it to you in 2 minutes. And that's, people often ask, how do you know where you reach the right level of simplicity? That's one of my markers. If I explain it to a colleague in 2 minutes over coffee, it's a really good sign, especially for the system structure. Maybe some of the code in there was a bit complicated, to do the scanning of the files efficiently. There's some clever code, maybe. But the overall architecture is very simple, and I think that's a really important point. If the modules themselves are a bit complicated, you can always replace them. If the architecture of the system is complex, is too complicated, it's over. You're stuck with a bad architecture forever. So I always like to spend lots of time on the system architecture until it's simple, and usually you notice it when you get to the right level of simplicity. Or do you ask a question, can we remove anything? And if you can't remove anything, it's probably because it's at the right level of simplicity. Next example from the Swiss Parliament. I used to work for the Swiss Parliament in 1999. We did a system to record the discussions in the chambers and publish the minutes, do the transcription, etc. And we had to do digital audio recording, which was a bit of a challenge in 1999. Today it would be boring, but it was a bit of a challenge. And especially we wanted the design of the system to make it impossible to lose more than 15 seconds. Whatever happens, if you have reliable, redundant disks, you cannot lose more than 15 seconds of audio. At the time, the players in this space for digital audio recording, Microsoft had a product. I forgot the name. They changed the names over time. But Microsoft had an audio recording server, and the big name at the time was Real Audio, Real Player. Anybody remembers that? Thanks. It shows that there's not only very young folks in the room, because that's probably gone now. But and then we were talking with these, big serious companies, and says we want to do the system, and we want it to be impossible to lose more than 15 seconds of audio. And they were like, high-level principal consultant stuff talking to us saying, yeah, no, but if a file is corrupted, then you might lose a bit more, but we have tools to repair it. So, they were, and we were not happy with the answer. We said, no, we want the design to make it impossible to lose more than 15 seconds. And then you think about it and you try and make prototypes and it takes a lot of time. It took us maybe 3 months to get there. What we did in the end, there's a bit of a simple drawing for that. We just recorded the audio packets on the network. We were using Windows at the time, and you had phone over IP. So, a caller on one of the systems, and then it sends RTP packets on the network, which is real-time protocol. It's an open format for sending audio in real time. Then the receiver gets it and plays it on the phone or on speaker. And then we just did a recorder for the RTP packets. Super simple. You open a socket, you listen, something comes, you put it in a database or something, and you're done. And then we just had one trick to do, is that on replay, we needed to manipulate the timestamps so the receiver thought that the packets were just emitted right now, and not 2 weeks earlier because we recorded the packets. Something super simple. I said 86 lines of code, something. With the people we have in the room, if we had to program that, I think by end of lunch we'd be done. It's really easy to do. It's really simple, and it cannot be, you look at it and say, you cannot remove anything. For storing, we use the same method as in the previous project. Chronological structures of folders, and then in the folders you put 15 files. Each file has 15 seconds of audio. That's, the 15 seconds. If you have reliable disks, you cannot lose files once they're committed to disk, so you cannot lose more than 15 seconds. Job done. Then you go to the customer and say, hey, this is the code. See, that's two pages of code, and this is the invoice. 3 months of work, 3 months of engineering. And the customer maybe goes, that's very expensive per line. Wow. But if they have the simplicity mindset, especially public administration, they work in pretty long cycles. The Swiss Parliament works in cycles of 4 years. That's the political cycle, and then technological cycle tends to have the same rhythm. So they wanted the thing to work for at least 8 years, maybe 12, maybe 16, and then it's worth it to spend more money to do something simpler because nothing can break. You want to review this code, I show it to you, you spend 2 minutes, yeah, that code is good, okay. So there's lots of value in working more to get something simple, but it takes work, and it also takes convincing. You need to convince the customer or the manager that we need to spend more time on this because it's not simple enough. And that's sometimes the challenge as well, because you need a long-term mindset vision to agree with that. And it depends on what you're doing. If you're doing software for a concert that's on Saturday evening, do whatever. I don't care. You do anything that works because you know that Sunday morning you're going to throw it all away. So that's a different mindset, getting something that works. But if you're doing software that has to live for a long time, I think it's really worth it to spend the effort to make it simple. Another example, a bit more recent, 2023, I've been doing, as I said, I'm a web guy, and I'm passionate about the web platform. There is a talk tomorrow by Alexander and Benjamin on the web platform stuff. I recommend that you listen to it. We had a discussion yesterday evening, and we were really on the same wavelength. So I did an example with web components to do a shopping cart. And then if you just came out of school and you learned to do components, or you read too many books about React, you're going to say, we need 8 components. There's a price, we need a price component, so we need a title component and a slider component, and that's about 8 components for a simple thing. Can we do simpler? Of course we can. So in my example, also, I needed a few iterations to get there. I don't think I had this structure immediately, but eventually I ended up with 4 components plus 1. So most of this can be done with plain HTML and web platform and CSS, so no components for that, just use what the platform provides. You need a component for the slider because it's a bit intelligent. You can type or use plus minus, so you need some logic there, so that's clearly a component. And a few other things. And the +1 component on the top right, that's the invisible component that helps accessibility, where you put some text saying what's in the cart so that the screen reader can read it, and it gives much better feedback to someone who's not, cannot see or cannot see well on the screen. Again, simple, but not simplistic. Reduce the number of useless components and add a very useful one that will help the accessibility of your thing. Again, to show this tension between simple and too simple. HTTP 09. Who ever used HTTP 09? I'm probably one of the oldest guys in the room. That was the very first version of HTTP that was created at CERN, very close to here. And it's so simple. Open a socket, send one line saying which file you want. The server returns HTML, it's done. And that's how the web started, because it was so simple. It took 3 minutes to implement on a Unix system. You write a script, wire it up with I forgot the service that does that, but it's super easy. And so I think you can clearly say that the success of the web has been driven by its simplicity and openness. So it's, again, one more reason to try to be simple. Something from my work. So at Adobe, especially in Basel, we create these systems for large-scale web content management. Many big companies have websites that use our stuff, including Adobe.com, which runs our web content management software since 20 years maybe. And now we have has anybody ever worked with Adobe Experience Manager? They're clapping cautiously because, big enterprise stuff. It's a bit, you will probably agree that it's a bit complicated. It could be simpler. So we actually created a simpler version, and we went extremely simple. You edit the content in SharePoint or Google Docs or whatever suits you. You already know these tools. And then we do the hard work of filtering out. If you ever tried to filter out a Word document, that's crazy. So we do it. We wrote code that cleans up the Word documents and transform them into a standardized semantic HTML. And then the presentation occurs. You just write some JavaScript code, web platform level, no need for any framework, nothing to do the rendering. A developer who has some idea about the web can do a website in 10 minutes with that. So I think they also, even in a space like enterprise software, where usually people tend to put lots of complicated stuff, you can go simple. And again, reusing what exists. In the audio recording example, the success was also based on using the good components in Windows that could do the audio codecs and everything. This was all provided. Don't reinvent it. Do what really differentiates your project. And this is the same approach here. The web platform nowadays provides lots of good things, so use them and don't put piles of stuff on top of them. So these are my examples. I'll be around I have to go by the end of the afternoon, but I'll be around if you want to. I have more examples. But these are really the key examples. And that's 3, 4, 5 examples over a career that spans, the first example was from 93, so that's a good number of years. And I have only a handful of examples. So it's rare that you can get to that level where you can say, I am proud of the simplicity of these things. And I am actually proud. But it's only a handful of them over several decades of working on that. But I hope you see the motivation for keeping things simple. How do you do it? As I said, I don't have a magic recipe. But the most important thing for me is putting simplicity front and center, or at least considering it as important as performance, as reliability. It's just one more axis to add on your evaluation of your software's quality. Is it performant? Is it robust? Is it appropriate? Is it simple? It's another axis, which is a bit hard to measure because performance, you can measure it with hard numbers. Simplicity, it's more an evaluation, but some rules of thumb, like I was saying, can you explain the architecture of your system in 2 minutes to a colleague over coffee? If you can't, maybe you should try to make it simpler. And trying, it's really a quest. It's as I said, maybe for the audio recording project, we probably did at least 10 iterations. starting with something that was way too complicated, then trying another one which was maybe too simple or not robust because it was not the right structure, try again, until you get to that level. It's really worth it if your software has to live a long time, and it would be expensive to maintain. And then you should not give up. Again, yeah, that's basics of an iterative process. Try again if you don't reach the good level. And I think maybe that's the most important thing I learned over my career in software. Don't be afraid to throw out your stuff. Sometimes we say, okay, this module is not fantastic, but it took a lot of time to write, so we want to keep it. But then if you think about it, if you're going to use it for 10 years, it's going to kick you in the ass for 10 years. That's not good. So throw it away, do something new. And that's also sometimes something you need to convince your management or your customers to do. They say, what, we invested 3 weeks of work with 5 engineers and you want to throw this away? Yes, I want, because I don't think it's good and I think we can do better. So that's, yeah, again, something where you might need to negotiate with your colleagues. But you can still measure. There's also one good factor to measure simplicity, and this is from Antoine de Saint-Exupéry. Perfection is attained. It's not when there's nothing left to add. It's when there's nothing left to remove. You have your thing is working, and if that's good, and if you remove anything, it should break. There should be nothing that you can turn off without breaking the thing. And you could very much add this to your definition of done. I hope you have a definition of done in your work process. You could add this. Is there anything that we could remove in this software? If yes, it's not done. Maybe it's good enough for now, you put it in production, but it's technical debt that you need to resolve to make it simpler because it's not simple enough. And I often find that the simplicity is beautiful and obvious. Again, when you see a simple system, oh yes. I'm a big fan of Unix, Unix and Linux systems because many things in there are so simple. You say, oh, yeah, there's nothing that we could remove. If you look at the options if you look at awk, for example, that's not the simplest thing in the world. But many things are the concepts, like the central concept of Unix and Linux is that everything is a file. That's a simple concept. It's easy to explain. And again, don't be simplistic. I'm giving you as many challenges as recommendations, but aim to be simple without being simplistic. Think about the rocket pen example. Think about the kazoo. Don't stay stuck in the 1930s. And your simplicity should be appropriate. So this is my coda. Simplicity is important. I would even say very important. And even, I would say the more important, the longer you expect your software to live. In my job, when we do these big websites for enterprises, many customers, they've been with us for 15 years or 20 years. So it's really a long-term view. And in there, the simplicity is really important. It's hard. I think you got this by now. It's not, you cannot get it like that. It's an iterative process to get there. But it is definitely integrable in your process. As one axis on your definition of done, as one axis on the measurement of quality, as one axis of discussions when you're with your colleagues. What you're doing, is it simple or do you think it's too complicated? Especially when you have junior people coming out of school. I know when I was coming out of school, I tended to make things way too complicated. Yeah, it's a communications protocol, so we need 7 layers. Sure, okay. Maybe it also works with 1 or 2 layers if that's good enough for your case. So that's it for me.